This is the last checkpoint, Module 7 solutions, okay, video solutions. We were asked to solve using substitution. So I move y to the other side, so y equals 2x, and I plugged it in as 4x times 3 times 2x. So 4x plus 6x is 10x, x equals 0, go back, x equals 0, y equals 0, and this is the solution, and I checked. We always check back in the original problem. So here I had to clean this up and move the terms around to get 2x minus 3y equals 4 and 2x plus y equals negative 4. We were asked to use substitution, so I solved for y, negative 2x minus 4, and I plugged it back in here. 2x minus 3y, and instead of y, I have this. I distributed 6x plus 12 equals 4, 8x equals negative 8, x equals 1. I'm sorry, negative 1, negative 8 over 8. And I have to go back and replace it in here. And this is negative 2 times negative 1, 2 minus 4 is negative 2. And I check back in the original problem. Same thing here, but this is elimination. So I decided to first divide here by 5. So I copy the first equation and I divide this one by 5, 1, negative 2, and 6. And then I multiplied this equation by negative 2 to eliminate x. I copied 2x plus 3y equals negative 16, negative 2x plus 4y and minus 12. This is gone, this is 7, this is negative 28. I got y equals negative 4. I go back anywhere you want. I prefer here. So x plus 8 equals 6. So then x equals negative 2. This is the ordered pair solution. I went back to check in the original problem. It works. Same thing here. I multiply both sides by 6 first to eliminate fractions. And then I multiply the second equation by negative 1. So 6 over 6 is 1. 6 over 2 is negative 3 in this case because it's a negative in front. And 6 divided by 3 is 2. And then I decided to eliminate x, multiplying the second equation by negative 1. I got negative 5 equals 5, so y equals negative 1. I went back here, replace negative 1, so negative 3 plus 2 would be negative 1. I went back and I checked. Solutions back in the original problem. Negative 1 is correct. Gauss-Jordan, I don't use Gauss elimination with back substitution. You're free to use it. I use the whole method, which is Gauss-Jordan. Gaussian elimination stops in the middle. I go all the way. So I copy the coefficients, 1, 2, negative 1, negative 2, negative 1, 1, and so on and so forth. And I realized that in order to get a 0 here and a 0 here, I need to multiply the first row by negative 2 to add it to row 2, the first row by 1, and add it to row 3. So I copy the row that I multiply. So negative 2 plus 2 is 0. Positive 4 minus 1 is 3. Positive 3 plus 1, positive 2 plus 1 is 3. Negative 4 plus 4 is 0. First row plus the last row. 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 At this point, I realized that I have to get a 1 in the middle here. So I divided second row by 3. Copy the first row, copy the third row, 0 divided by 3, 3 divided by 3, 3 divided by 3, 0 divided by 3. At this point, I will use the 1 to eliminate the negative 2 and this one to eliminate negative 1. Multiply this row by 2 to add it to row 1. Multiply this one by 1 to add it to row 3. I copy row 2 and the first column cannot change. So 2 times 1 minus 2 is 0. 2 times 1 minus 1 is 1. 0 times 2 is 0 plus 2 is 2. 1 times 1 minus 1 is 0. 1 times 1 minus 3, negative 2. 1 times 0 is 0, minus 2 is minus 2. At this point, the first two columns are done. I need to obtain a 1 here, so I will divide row 3 by negative 2. Copy the first row, copy the second row, and divide just the last row by negative 2, and I get this. So now I multiply this row by negative 1 to add it here, and this row by negative 1 to add it here. The first two columns cannot change, so just copy them again. So negative 1 times 1 plus 1 is 0. Negative 1 times 1 is negative 1 plus 2 is 1. Negative 1 times times -1 times 1 plus 1 is 0. -1 times 1 is -1 plus 0 is -1. So the solution is 1, -1, 1, and I checked. I went back to the original problem. Please follow the process here. It's the same, has the exact same steps. You get 0, 2, 2, you go back and check. Same here. What I did from the very beginning with this problem, I realized that I needed the 1 to be at the first row, first column. So I swapped these two rows. You can always do that. That's one of the legitimate operations to make it easier. Same thing here. I swapped these two because I needed the 1, 1, 1, 1, 4, and then 2, 1, -1, 1, and then 2, -3, 1. So everything was the same exact same steps. And I got the solution. I went back to check. Here, these are nonlinear systems. So I eliminated y, multiplying the second equation by -1. And I got x squared minus 2x equals 3, factor, got 3 and -1, go back to any of the equations to get the corresponding y values. For x equals 3, I got y equals -5. For x equals -1, I got y equals 3. The solutions are 3, -5, -1, 3, and I went back and checked. Same thing here. I eliminated x squared, multiplying the first equation by -1. So negative, negative. So this becomes y squared minus 16y plus 64 and minus y squared and plus equals 36. These two go away. Linear equation, 7/4 for y. And I plugged it in, and I got two values for y. One value for y, but two values for x, because I have plus or minus when I take the square root. Square root of 31 over 4. So I got these two solutions, and you can go back and check. I checked both of them, both work. Same thing here, but by substitution, I moved y and moved 3. So y equals 4x minus 3, and I plugged it in. Performed all the calculations and got two x values, 1 and 19 over 29. I went back to here with x equals 1, and I got y equals 1, and the other option with x equals 19 over 29. And I went back and plugged it in, and here are my calculations, 19 over 29 and -11 over 29. We go back and check in the original system, please, always. Here we're asked to determine the dimensions of the rug, knowing that the diagonal is 15. So we have x squared plus y squared equals 15 squared by Pythagorean theorem, and x times y is 108. I solved by substitution, and I plugged it in the first equation. Multiply both sides. I use the, as we did in chapter 2, I use the substitution, and I replaced x squared by t, so this is t squared minus 225t plus 11,664. I used the quadratic formula, and I got 144 and 81 for x squared. And when we take the square root, of course we get two options, plus or minus, but we are talking about the distance, so it has to be only plus. So it's 12 by 9 or 9 by 12, which is the same thing. And we always go back and check in the original problem. Section 5.5, I think that's, yeah, the last two sections of this course. So we have systems of linear and nonlinear inequalities. We have to graph the line, so I first write the equation. I find 2 points, when x is 0, y is 4, when y is 0, x is 2, and the points have to be the x and y intercepts. So this is the line y equals, as you see here, y equals -2x plus 4. At this point, I see that the line divides the plane into two pieces, into two areas, two regions. I plug in 0, 0, 0, 0. I get the 0 is less than 4, which is true. So then I will shade in this area, which represents y less than -2x plus 4. I repeat with the other one, finding the two intercepts, the x and y intercepts, in the same way. When x is 0, y is such and such. When y is 0, I get x. I graph. At this point, I stop. I plug in 0, 0. But 0 is not less than -4. So I cannot shade in the area with 0. I have to shade in the opposite. And now I have to intersect this region with this region, which gives us the solutions. Not included on the line. See, these lines are dashed because we do not have the equal symbol in the inequalities. Here, this is a circle. They are both circles, and they're not contained, right? So both have to be dashed curves. So central at 0, 0 with a radius of 1, centered at 0, 0 with a radius of 3. So first we start with the first circle. And the first circle, we check with 0, 0. This is the first circle, and check with the 0, 0. You see the arrow here tells you which one it is. So 0, 0 is greater than 1, no. So I cannot shade in the inside, I have to shade in the outside. Then when I plug in 3, 3, so I determine this circle, also not a solid curve. When I check with the origin, it works. 0, 0 is less than 9. So it's the inside of the big circle, but the outside of the small circle. So it's this donut where they intersect. So that's the solution to both. The same thing here with 2 to the x. We know the graph. It passes through 0, 1. And when we plug in 0, 0, 0 is less than 1. That's true. So I have to shade in this area as you see it here, as you see it here. And then the circle, it's a solid circle with the radius 4 and centered at the origin. When I plug in 0, 0, that's correct. 0 is less than or equal to 16. So it's the outside of the exponential dashed and the inside of the circle. So it's this area, the orange area. Same thing here. They're all lines between x equals 1 and x equals 2 and less than y equals 3. And you have to shade them step by step. And these two graphs are intersecting. So it's this orange area. Last section, 8.1 on sequences. Here we're asked to find the first 4 terms, and I plugged in 1, and then 2, and then 3, and then 4, and I got these numbers. The same thing here. I plugged in 1, I got this. I plugged in 2, I got this, and then 3 and 4. Same thing here, but this is a recursive formula, right? So A1 is given already. So this is 3 times the previous number minus 1. 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 Here I recommend don't plug this in the graphing calculator, just simplify. 20 factorial can be rewritten as 20 times 19 times 18. Why did I stop at 18 factorial? Because I see this. 2 factorial is 2. And I simplified, and I got 10. So it's 190. Here, step by step, you can also plug in the graphing calculator. When k is 1, I have 1 minus 3, 1 plus 2. When k is 2, 2 minus 3, 2 plus 2, till k is 4. And I added them up to get this. Here, I recommend always simplify. And if you do that, you have y plus 2, y plus 1 times I factorial. I plus 2, I plus 1, I factorial, and simplify these. So when you multiply, you get y squared plus 3y plus 2, and you put it in. You don't have to if you don't want to. You can plug in the calculator and get that number. So to condense this, you see 5, 5, 5, 5, 5 from I equals 1 through 12. When I is 1, I get this. When I is 2, I get this. When I is 3, I get this. And when I is 12, I get this. Same thing here. 1, 2, 3, 4, n. So it's I. 9, 9 squared, 9 cubed. So 9 to I. When I is 1, I have I over 9. When I is 2, I have 2 over 9I squared. When I is 3, I have 3 over 9 to the third power. So till n. I hope you find this helpful.